Welcome to the lab tutorials of Digital Design and Computer Organization. I am Sahana RS, Assistant Professor, Department of Information Science and Engineering, Rajiv Institute of Technology, Hassan. In today's video, we shall discuss about the third experiment, that is design a Verilog HDL to implement a simple circuit using structural, data flow and behavioral model. Okay, this means we need to consider a circuit, a simple circuit. Then we have to write a Verilog HDL. The Verilog HDL can be written in three forms. The one is structural, the other is data flow and behavioral. Let us first come to know what is structural, data flow and behavioral. Then we can discuss about the program. What is structural model? Structural modeling is the lowest level of abstraction in Verilog. It is also called as gate level modeling because we only describe hardware in logic gates and their interconnection. In structural modeling, we use the primitives that are already predefined. We use predefined primitives. The examples are AND, OR, NAND, NOR, XOR and XNOR. So here we have an example of declaring an AND gate. Okay, the primitive name is and we have to specify which is the output and we have to specify which are the inputs to that gate. So here is an example of an OR gate. Here Y is the output and A, B, C, D are four inputs to the OR gate. Likewise, we can define all the gates and we can design a circuit. Then we have is data flow modeling. Data flow modeling describes hardware in terms of flow of data from input to output. That means how inputs are operated in order to get the output is shown here. The example of an AND gate is shown here. We are using the keyword assign. We are assigning output to a value we are getting after operating A and B. Okay, so here the output is equal to A and B. Equal is an operator used to assign a value to the output from the inputs. Okay, we here AND gate functionality is executed in an above statement. We use ampersand operator. Likewise, for OR we use a pipeline. For NOT we use a cap. For XOR we use a cap. Okay. This describes the relationship between the input and the output. The third model is behavioral model. This is the highest level of abstraction provided by Verilog. The design at this is similar to an algorithm. That means how your circuit is going to be worked. The whole algorithm will be specified in this behavioral model. This is very similar to the C programming. Okay, let us consider an example of AND gate. Here always specifies we are going to execute it repeatedly. Then always at A or B. Here in the bracket we have the condition A or B. At both the condition I need to run this gate. Here we can use if else like conditional statements what are used in C that can also be used here. We can use branching statements here. But it starts with begin and it will be ended with an keyword end. Okay, so here what the program says is if A is equal to 1 bit binary 1 and B is equal to 1 bit binary 1, then my result Y is equal to 1, or else my output Y will be equal to 0. So this is the characteristics of AND gate. AND gate output is equal to 1 only when A is equal to 1 and B is equal to 1. In all other cases, the Y value is equal to 0. This is the variable, this is the behavior of our AND gate which is described using an Verilog HDL. Therefore, this is called behavioral logic. Now, let us consider a simple circuit shown here. We are having three input. Two inputs are given to an OR gate and the output of OR gate and the input C is given to an AND gate. So now we shall try to write a Verilog HDL for this circuit. Three modeling of Verilog HDL are discussed here. Truth table for the circuit given. The Y value is equal to 1 when input BC is equal to 1 and A is equal to 0, and also at A and C is equal to 1 and B is equal to 0, and all the three inputs are equal to 1. Now let us see how to write three modeling for this circuit. The first one is gate level modeling. Every Verilog module starts with a keyword module and ends with a keyword end module. Okay, everything has to be in the lower cases. All the keywords has to be in lower case. Next, after module, we can give a name, a simple circuit or whatever the name you require, but the name should not start with a numerical value. The whole name can be alphanumerical value and with an underscore special character, but the name can't start with a numerical value. It can start with an alphabet or an underscore. After this, we need to specify the ports which are used in your program. Here we are using three inputs, input A, B and C, and also output Y. Okay, observe this diagram. Okay, we have A, B as input, A, B, C as input and Y as output, and we have S1 as an intermediate value. This is neither considered as an input and neither considered an output. This is an intermediate value which comes from an OR gate. Okay, that is an output of an OR gate and it is an input for an AND gate. Like these intermediate values are specified using wire. Okay, you can observe after the module we have given a name. Inside the bracket we have specified the port. This can also be written in other way, that we just specify A, B, C, D, A, B, C and Y and end it. Okay, after this we can declare which are my inputs and which are my outputs in the program itself. Okay, so this can be written as input A, B, C, end it with an semicolon. Then we have output Y, end it with an semicolon. In the both ways we can declare input and outputs. Initially we can declare only the port names and then we can declare what are these ports specifies. That means which are inputs, which are outputs. Then we have to specify which is, if any intermediate values are present, I have to specify that intermediate value. Okay. Now again consider the circuit. In gate level modeling or structural modeling, we need to write the operation in the form of gate. We have two gates, one is OR gate and one is AND gate. Now we have to write a primitive OR gate. So okay, OR, small letter OR is used to represent OR gate. Here O1 represents the instances for the OR gate. This instances is an optional. You can write or you can just write OR gate. If there are multiple OR gates, we use this instances. The first OR gate to represent OR gate 1. Here O represent OR gate and it is representing first OR gate what we are using. You can give any instances. Okay, or it is optional, you can leave the instances and write the program. Okay, then we have to specify the output first followed by inputs. So observe the OR gate. The output of OR gate is S1, that is an intermediate value. That S1 is the output of OR gate and the inputs are A, B. The next gate is AND gate with an input S1 and C. So the inputs are S1 and C, the output is Y. Okay, after this we need to, so every line has to be ended with a semicolon. Okay, but except the end module line. In Verilog programming, all the lines has to be ended with a semicolon except end module in this. Okay, and all the keywords has to be in the lower cases. So this is the gate level modeling for this simple circuit. let us see the data flow modeling of the given circuit. In data flow, we use assign keyword and we specify the operations using some of the operators. Now let this again same. The program has to be started with the keyword end. Started with a keyword module and end with a keyword end module. This inputs and outputs can be specified inside the module bracket or it can be specified outside. You can write in either of any modes. Then we need an assign keyword. To what we are assigning? We are assigning a value to output y. The value assigned is, first we have to perform an A or B operation using pipeline. Okay, A or B is represented using pipeline. The result of A or B has to be AND operated with the input C. So these parentheses are indicated which operation has to be performed first and next which operation has to be performed. Here observe the bracket, A or B has to be performed first, then that is operated with C with AND operation, ended with the keyword end module. Next we have is behavior modeling. Okay, the code looks lengthier but it is very simple. Similarly, the behavioral model also starts with a keyword module and ends with a keyword end module. So this one starts with a module and ends with an end module. After that we need to give us name for the module and we have to specify which are the outputs and inputs. In behavioral model, output is represented as register Y. Okay, in the all inputs are represented with a keyword input but outputs are represented with a keyword register Y. Now let us see how to write a behavioral model. In behavioral model we have a block called always block. This always block tells us what should happen under certain conditions. Okay, always at this star represents some of the conditions. Always at this condition I have to go through the following procedure. Okay, here star represents, it is, we are writing this program for combinational logics or logic gates. Here only equal to assign operator can be used but we cannot use less than or equal to operator. Here we can observe we have only equal to operator here. Only this equal to operator can be used if you use star inside always condition. Okay, this is always at we have to give the conditions. You can give positive edge, negative edge. That means if you give a clock, only at the positive edge of the clock we have to get the output at, or always at A. If you give the input A, only at that case I need to change my inputs or I need to change my outputs. That conditions are given inside this bracket. Here star represents only equal to assignment operator can be used inside this always block. So everything has to be in this lower cases. Then the always block always comes with a keyword begin and end. Okay, after starting always, like after starting, if you write a parenthesis here, after writing this always condition we need to start a begin keyword and it has to be ended with the keyword end. Then after that we have to write the behavior of our circuit. The marked part which is showing on the screen is the behavior of the circuit we have considered. Here we are deciding a case. Okay, at what cases output should be high or what cases output should be low. This is written according to the truth table. When we have binary input 000, the output y is equal to 0. You can observe the truth table. Here the output is equal to 1 only when A is equal to 0, B is equal to 1 and C is equal to 1. That is 0 0 0 1 1 combination and 1 0 1 combination and all the one combinations. So observe the program. At 0 11 1 we have output is equal to 1, and at triple one we want to write output is equal to 1. Here if your input doesn't satisfy any of this following, then you will get a default condition that is equal to 0. If any of this condition is not satisfied, then your output will be equal to 0. Now let us see how to execute this using Xilinx software.